Alright, ladies and gentlemen, it is time to explore the wonders of similarity. Mostly triangle similarity, but we'll see what happens. Dilate triangle ABC from the origin by a scale factor of 1/2. Label the vertices of the image. No work needs to be shown. So if we're going to dilate from the origin, all we have to do is multiply by the scale factor. Multiply what, you ask? Well, the original point. So the original point A is -2, 2. So that's -2, 2. The original point B is 4, 3. And the original point C is 2, 0. So to find A prime, I'm going to multiply these coordinates by 1/2. So basically I'm dividing each of these by 2. So if I divide both of these by 2, I'm going to get -1, 1. And then for B prime, if I take 4 and I divide by 2, that's going to be 2. 3 divided by 2 is actually 1.5. Okay, divide by 2, divide by 2, that's 1, 0. So these are the coordinates of the image. So -1, 1, that's right there. 2, 1.5 is right here. And 1, 0 is right here. So this tiny little triangle is going to be the image. Okay, and that was A prime, B prime, and C prime. For number 2, we are given two similar triangles, and we are asked to write the similarity statement. So we have to get the order right. Don't assume that it's oriented the same way. Don't assume that 30 corresponds to 8. Instead, we need to consider the sizes. Let's see, which one of these is the biggest? 30 is the biggest. Which one of these is the biggest? 15. That means these are definitely corresponding. Which is the smallest? 16. I'll put a square on that one. 8 is the smallest. And then you can see the one that is left empty. I guess I'll put a triangle on that. The middle ones. So those are corresponding sides. Okay, now let's use that to sync up corresponding angles. So angle A, you see, is between the circle and the triangle. So here's the circle and the triangle, and that is angle D. Alright, angle B is between the circle and the square. So here's the circle, here's the square, so that corresponds to angle E. Okay, and that only leaves angle F left. Okay, we're also supposed to find the scale factor that changes ABC into the other triangle. So that means we're supposed to view ABC as the old triangle, and we'll view DEF as the new triangle because we're changing ABC into DEF. So the way we do the scale factor, which I'm going to call K, the scale factor is always a new length divided by the old length. Okay, you have to use corresponding sides. So for example, if I use the squares, then that would be 8 over 16. All right, has to be new over old, which in this case is 8 over 16. So we're supposed to write this as a reduced fraction, so that is going to be 1/2. So that is the scale factor. All right, we're going to do the exact same thing for problem number 3. Which of these is the biggest? This is the biggest. Which of these is the biggest? Boom. That means these are corresponding. So I circled them both. This is the smallest, and on this triangle, this is the smallest. So that means these are corresponding. That leaves this and this to be also corresponding. Now, angle A is between the circle and the triangle. Well, here's the circle, here's the triangle, so F is the corresponding angle. Angle B is between the triangle and the square. So here's the triangle, here's the square, so angle D is the corresponding angle. So that's FD, and that just leaves E. Now we need to find a scale factor that changes ABC into the other triangle. So that means ABC is supposed to be the old triangle, and this is the new. So of course, when we do a scale factor, we take a new side and divide by the old side, corresponding sides, of course. So if I pick the squares, for example, new over old, that would be 3.8 over 5.7. Okay, and now I'm supposed to write this as a reduced fraction. So let's see what happens. Okay, 3.8 over 5.7. Okay, I'm going to have to hit the toggle key. 2/3. So the scale factor is 2/3. For number 4, we need to find all missing angles. Well, we're given angle A is 43. But angle A corresponds with angle D. So that means angle D is also 43. I see we're given angle F. Well, angle F corresponds with angle C. So that means angle C is also 60 degrees. Alright, now we have 2 out of 3 angles in a triangle, and we know that they have to add up to 180. So if I take 180 and I subtract 60 and I also subtract 43, then I get 77. Alright, so that means this angle B is 77, and for the same reason angle E is 77 degrees. Okay, number 5, we're not given a picture, so we have to draw our own. Triangle FGH. Okay, so here's triangle FGH, and that's supposed to be similar to another triangle, KML. So I'm going to be very careful to put the letters in the same order that I did the first time so that my corresponding parts will line up. So let's see. The measure of angle F is 38 degrees. So I'll put a 38 right there. The measure of angle L is 71 degrees. So this is 71 degrees. FG is 14. Okay, so that's going to be 14. FH is 18. So that's going to be 18 right there. KM is 10.5. So I'm going to put a 10.5 right here. And ML is 21. Okay, so this is going to be 21. Okay, let's start by finding all of the missing angles. Let's see, angle F and angle K are corresponding. So if F is 38, then K is also going to be 38. So that's going to be 38 degrees. All right, angle L is 71. That means angle H is also 71. So that's going to be 71 degrees right there. All of the angles in a triangle have to add up to 180. So if I take 180 and subtract the two angles that I've got, so minus 38 and minus 71, well, look, that gives me 71. Again, interesting. So that tells me that angle G is also 71. So that means, this is actually kind of weird. Because, alright, if these angles are equal, it seems like that would make this an isosceles triangle, but 14 and 18 are not the same. So I think that's kind of a little bit of an error, but I'm going to ignore that for now and just go ahead and put the 71 degrees. And that's for G and for M. Well, now we need to find the unknown sides. So for GH, I'm going to call that X. And for KL, I'm going to call that Y. So those are the two variables I need to find. So let's see. I'm going to pick one of these triangles to be old and one to be new. So I'm going to call this the old, and I'm going to call this one the new. And what I know about similar triangles or similar polygons of any kind is the corresponding sides are proportional. So new over old will always equal new over old. So as I match up my corresponding sides, new over old, so for example that would be 10.5 over 14. Okay, that's a pair of corresponding sides. Now if I want to find X, X and 21, those are corresponding sides, but I need to do new over old, so that'll be 21 over X. So I can use this to find X. So of course I'm going to cross multiply. So if I do this diagonal, that's going to be 10.5x. And if I do the other diagonal, 14 times 21. That's 294. And then I would simply divide both sides by 10.5. So that's 28. So that means that GH is 28. Okay, and now once again I'm still doing new over old equals new over old, but this time I need to involve y. So y and 18 are corresponding sides. So if I do new over old, then that's going to be y over 18. Now I can still use the 10.5 and the 14, still works. So 10.5 over 14 once again. So I'm just going to do the same exact thing. Cross multiply. So that's going to give me 14y. And if I do the other diagonal, 18 times 10.5. That's 189. And then I need to divide that by 14. That's 13.5. So that's KL. All right, a 5.4 foot tall woman casts a 6 foot long shadow. All right, so here's a woman, and here is her shadow. And that forms a triangle. Okay, so she is 5.4 feet tall, and her shadow is 6 feet long. A nearby building casts a 74-foot shadow. Okay, so here's a building. And here is its shadow. Okay. 74-foot shadow. So this is 74 feet. How tall is the building? So I'll put an X right there. These are going to be similar triangles. So, and I've lined up the corresponding sides. So I'm just going to set this equation up by doing new over old is equal to new over old. It doesn't matter which one is new and which one is old. I will go ahead and call this one old, and I'll call this one new. So when I set up my proportion of corresponding sides, new over old, that's going to be x over 5.4. And new over old, that'll be 74 over 6. So I just need to cross multiply, but I want to reduce the 74 over 6. So that's 37 over 3. So that means what I really have is x over 5.4 is equal to 37 over 3. So now I will cross multiply using this diagonal, which gives me 3x, and I will multiply along this diagonal. So let's see, 37 times 5.4, 199.8. And then I would divide both sides by 3. $66.6. All right, so that would be the height of the building. Okay, so Mike is 6.2 feet tall. He stands 10 feet away from a flagpole. The tip of his 7-foot shadow is in the same spot as the tip of the flagpole shadow. How tall is the flagpole? So ultimately, we're looking for this. Now, the key to this type of problem is to draw the two triangles separately. All right, we've got the smaller triangle involving Mike and his shadow. And then we've got the larger triangle involving the flagpole and its shadow. So I would recommend drawing these two triangles separately. Okay, so here is Mike and his shadow. And then here is the flagpole and its shadow. Okay, now remember, ultimately we're trying to find X. So let's start with a small shadow. The bottom, with the small triangle, the bottom side is 7 feet, and then the vertical part is 6.2. Okay, now let's do the bigger triangle. Okay, the vertical part we don't know. The horizontal part, got to be real careful. It's definitely not 10. All right, the horizontal part is 17. Got to add these two together. Total of 17. So now it becomes pretty straightforward. Because when we write our proportions, we always do new over old is equal to new over old. Okay, so let's say if I call this one old and this one new. Then when I do my corresponding sides, the x in the 6.2, all right, new over old would be x over 6.2. And then if I do the other corresponding sides, new over old, that would be 17 over 7. And then, as always, we cross multiply. So this is going to be 7x. And then if I do this diagonal, it's going to be 17 times 6.2. 105.4. And then we divide by 7. Getting decimals. I'm just going to write this down for now. 15.057. Okay, feet. Now, I'm a little nervous because they didn't say, you know, that we could round to the nearest 3 decimal places or anything like that. But in a word problem like this, this would be the most meaningful answer. But just to be on the safe side, I'm going to convert this to a fraction by hitting the toggle key. You know, I'm sure that this answer is the answer that they really want, all right, because it makes the most sense. But technically the directions usually say, unless we specifically say otherwise, you can use a fraction or an unrounded decimal. And this is a rounded decimal, so that would break the rules. So 527 over 35. Feet. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.